Welcome to Brain Vision.
In this problem, we have to find the angular velocity of the rod BC, which is omega BC. In order to calculate this angular velocity, let's find the energies corresponding to this system. So initial kinetic energy will be Ti, which is equals to 0 joule, as system is at rest initially. The initial potential energy corresponding to the weight is written as Vgi, which is equals to 2 mgyi. So this is written as 2 into 12 kg into 9.81 meter per second square into 1 meter of sine 60 degree. So this will give us the value for this Vgi, as Vgi is equals to 203.90 joule. Similarly, we can write the equation for Vgf, as Vgf is equals to 2 mgyf. So this is written as 2 into 12 kg into 9.81 meter per second square into the value of y2, which is equals to 1 meter into sine of 30 degree. So this will give us the value for this Vgf, as Vgf is equals to 117.72 joule. Now let's calculate the initial elastic potential energy, which is a Vei. So this is equals to 1 divided by 2 kxi square. So this is written as 1 divided by 2 into 20 Newton per meter, square brackets open. Here we can write 2 into cosine of 60 degree, 2 into 2 cosine of 60 degree, that is 2 here, into minus 1.5 into meter whole square. So this will give us the value for this Vei, as Vei is equals to 2.50 joule. Similarly, we can calculate the final elastic potential energy as Vef, which is equals to 1 divided by 2 kxf square. So this is written as 1 divided by 2 into 20 Newton per meter, square brackets open. Here we can write 2 into 2 cos of 30 degree minus 1.5 into meter whole square. So this will give us the value for this Vef, as Vef is equals to 38.58 joule. Let's calculate the final kinetic energy, which is Tf. Tf is equals to 1 divided by 2 Ia omega AB square plus 1 divided by 2 Ig omega BC square plus 1 divided by 2 Mr Vg square. We call it equation number 1. Now let's write the relation for this Ia. Ia is equals to 1 divided by 3 m RAB square. Similarly, we can write the relation for Ig, as Ig is equals to 1 divided by 12 m RAB square. We can write Vg, as Vg is equals to square root of 3 meter into omega BC. We can also write this Vb, as Vb is equals to 2 meter into omega BC, and we can relate this Vb with AB, as Vb is equals to omega AB, as Vb is equals to 2 meter into omega AB. So from these two equations we can write this omega AB is equals to omega BC. Now using these relations we can write equation number 1 as TF is equals to 1 divided by 2 dot 1 divided by 3 MRAB square omega BC square plus 1 divided by 2 dot 1 divided by 12 MRAB square omega BC square plus 1 divided by 2 MR, and here we can write square root of 3M square omega BC square. Now let's put the values into this equation. We can write this one as TF is equals to 1 divided by 2 dot 1 divided by 3 into the value of M, which is 12 kg, into RAB, which is equals to 2 meter square omega BC square plus 1 divided by 2 dot 1 divided by 12 into 12 kg into 2 meter square, and here we can write omega BC square plus 1 divided by 2 into 12 kg into square root of 3m square and omega BC square. So this is simplified as TF is equals to 28.0 kg meter square into omega BC square. Now let's apply the law of conservation of energy, which is written as Ti plus Vgi plus Vei is equals to Tf plus Vgf plus Vef. Now let's set the values into this quadrant. So 0 joule plus Vgi, which is equals to 203.90 joule plus 2.50 joule is equals to 28.0 kg meter square into omega BC square plus value of Gf, which is equals to 117.72 joule plus 38.58 joule. So from here we can write the value for this omega BC as omega BC is equals to 1.34 radian per second. So this is the required answer. Thank you.